Hello everyone. In this short tutorial, I'm going to show you how to use a specific function block which comes with the SoftMotion library in it. It is called MC PositionProfile. It's for movement control. You can see over here that in the help of the CODESYS, in the line help of the CODESYS, you can see that it's a part of SM3 basic library documentation. In the SM3 basic, it's a POU. It's related to the movement, and it is called MC Position Profile. Basically, it's a function block which is designed for commanding a time position locked motion profile. So we have a time position locked motion profile, and I will show you in action how to do this indeed. Yeah. Over here we have an example. You can see that there are different delta times indeed. So we start from 0. This is time equal to 0. Then we have dt1. This is the second time instance. Then after dt2 there will be the third one. After dt3 there will be the fourth, and so on and so forth. And for each one of them we have a position which is denoted by these red dots. So initially we start at 0. Then the first position, second position, third position, fourth position, and so on and so forth. Basically, we need to have something like this table over here, which determines after a given delta time the position in which we want to have for our indeed axis. Okay. Over here you can see the main inputs and outputs for this function block. The axis is one of the inputs and outputs in it, in-out. So we need to connect an axis as the main input to it. It's a reference to the axis. And the next main indeed variable that we have for this function block is the time position. It's a reference to the time position description. It's a data type of MC TP ref. TP refers to time position indeed. If you follow it, we'll follow and then we'll go back. If you follow it, you can see that it's in the form of a structure. It has different fields. The first field is the number of the pairs. The second field is absolute. We will see this in action, whether the kind of movement that you want to have for the positions are in the form of absolute or relative. If it's true, it means that we are dealing with the absolute position. If it's false, it means that we are dealing with the relative position. And then the third field is the MC TP array. It is an array of SMC TP, and SMC TP itself is a structure. And for that structure, we have two fields. The first field is the delta time, delta t, and the second field is the position. Delta time will have the data type of time, and it should be indeed given in the form of time #0 ms milliseconds in terms of milliseconds, and the position is the type of L real, long real. Yeah? Okay, so now let's see how we can use this function block in action. I already have created a CODESYS project. You can see it open over here. The device that I have chosen is the CODESYS SoftMotion Win364. And once you have this device selected, after the generation of the project, you will have this field over here, SoftMotion General Axis Pool. I have chosen CFC as the programming language, but you can use any programming language that you prefer. So the first step is to right click on the SoftMotion General Axis Pool and then choose Add Device, and over here we have the virtual drives. We select the SM drive virtual, and let's call it Axis X. For now, for this project, I will work with a single axis. Later I will show you how you can deal with multiple axes as well. Okay, looks like I have clicked the Add Device 2 times. I will remove this later, but you can see that after we add the device, it appears over here. Let me just remove the one from there. So now we have the axis underline x added to our project. If you go to the general, you can see the general specifications for it, the velocity, ramp type, there are some limits as well, software error reaction, and so on and so forth. I may discuss these indeed properties in a separate video later. Alright, so let's come over here. We want to use that function block, yeah? Indeed, that's the main purpose of this tutorial, the position profile. For that, we need to power up the drive first, the virtual drive that we have. Let's insert a box, empty box, and then you should remember from the previous video that we need to insert MC underline power in order to power up the drive. So I call it MC underline power underline X, which is an instance of the MC underline power. We need to bring an input. If we connect it to the axis input of the MC underline power, then we can look for the available indeed axis that we have, the drives, and it's over here, axis underline X. Alright, so now we are kind of done in terms of powering up the axis. However, something which remains here is that we have two options, whether to provide inputs to this enable to the regulator on and the drive start input separately, or we do it through the visualization. We need to add the indeed in the application we need to add the visualization, and there we can have the visualization elements which correspond to this MC underline power. Again, this is something that I have already covered in the previous video, but I just do it again over here to give you more details in it. So let's wait for the visualization to be added, and then I will show how we can power up the axis. Okay, so it takes more than I expect. Alright, so here we go. We have the visualization. Now, if we look at the visualization toolbox, we should be able to find out the MC underline power. Either we can look for it by typing the name. You can see that we have MC underline VZU underline MC underline power. We have in the two different versions. Let's take the new one, which is different in terms of the appearance mostly, and then in terms of the value we need to select the MC underline power underline X function block that we have in our program. Okay, so we are kind of done in terms of powering up our axis. Let's also take the linear drive associated with the axis X that we have, just to have an understanding of how the axis is going to move, how we will have the movements. And then we can go back to our PLC underline PRG program and insert an empty box and look for the MC underline position profile. So this is basically the function block that we are going to use and are going to learn how to use. Let's click on the OK. So you can see over here that there are multiple inputs. The axis should be connected to the same axis. The other input is the next indeed input is the time position. Okay. For time position, one option would be, which is in my idea easier, would be to insert an input connected to the time position input and then give it a name. Let's call it time pose underline X, and I call it 01 because I might enter indeed create the second one later. When I press on the enter, the auto declare opens, the auto declare window opens, and you can see here that the type is given here. The name is what I have indeed determined, and we have an option for initialization. This indeed will help you in order to initialize or to give the values properly. If I open it, you can see that we have the fields for the structure. As I explained earlier, we have the number of pairs is absolute, which is true, meaning that it will be the absolute kind of movement. And then we have the MC underline TP underline array elements. You can see that it goes up to 100 elements. Something to start here is to try to initialize it. Okay. For as the first element, we can set the value. So it's 0 milliseconds. I'm going to make it 500 milliseconds. And then I need to apply the value to the selected line. The position that I want to have over here is 100. And then I apply it. Then let's go to the next one. The next delta time that I want to use is still 500 milliseconds. And the position that I want to go is 250. And we are talking still about the absolute kind of movement, okay? So that's something important to keep in mind. Then the next delta time is 1 second. And the position that I have in mind is 500. For the next one, 200 milliseconds, and we went up to 500, so I will go back to 350 this time. Then another 500 milliseconds, and I just use 150. You know that you can depending on the kind of the movement that you want to have, you can indeed insert different values over here. Yeah? I just want to show you how we can perform this kind of movement using an example. So the values that I insert here are not that important, yeah, in terms of the kind of the movement. All right. Now that we have initialized the structure, we can click on the OK, and you see how it will appear in the variable declaration area. So the initialization has the initialization that we did indeed has inserted these values over here. Let's go back to the visualization and insert a visualization element for position profile. We can take it from here. Once we insert it in our visualization, this window will appear in order to assign it to a function block that we have, and we have a single one, which is MC underline position profile underline X. And if I click on it, it will be indeed configured. So basically what we will have over here is that when we execute the position profile, the movement will appear here. So let's try it right at this point. Let's log in. We are in the simulation mode already. And now I will show you how the movement will be. Over here for the MC underline position profile, you can see that the array size is also one of the input fields. So we can determine it from here. Let's say we want to have five elements. Position scale, we keep it as 1 and we don't give an offset. We can try this later as well. So if I try to execute, there will be some error appearing. And I hope you know why it happened, because we haven't powered up our drive. So first we need to enable the drive, then set the regulator on, and then we need to start the drive. Now we can come back to our position profile. If I create a rising edge over here, you see that the movement is started. And it follows whatever we have given, depending on the number of the elements that we provide. And once it is done, the done bit will be true. So it's still busy. And now it's done. And it follows, the movement in it follows the values that we provided. Okay, and over here, you should also keep in mind that we have the absolute kind of movement. I can try to make this relative. And let's see what happens to the... You see that the behavior will be quite different, yeah? It is done. Now you can't even see the exact position, because the movement happened in a relative way. So each time we kind of accumulated all the values that we had. We didn't go back to 250, but 250 was added. So if I make it true again by pressing F7 and Alt F7, and then executing the movement, it went back to 0, and then we have this kind of movement over here. You can have indeed multiple time position sets indeed in terms of an array, and then switch among them by using a multiplexer. Let me just show you how you can do it. I just make it 2, but now you see that it will be in the form of an integer, yeah? Instead, you can try to find it from there, or you just copy whatever we have here, paste it, and give the name of 2 to it. And then for the delta time, indeed, you can also create a variable. I call it dt. Let's give it 500 millisecond as the value. Okay, and then we can indeed okay, so let me make it delta t, and then we can use that variable over here instead of explicit value that we have for it. I will change this, and then I will use a max element to show you how we can switch between these two. And in it, I'm going to show you to make this one as the relative movement. Okay, so in terms of the values, let's set, since this will be used as a relative kind of movement, let's make it 100, 100, 100, then minus 100, minus 100, plus 100, and minus 50. And then we will see what happens in action. But over here we need an element. Let's insert a box. For our box, we can either look for it as max. So it is indeed a multiplexer. So for our multiplexer, we have now by default 3 inputs. One input to the multiplexer will be indeed the select input, and the other inputs will be the actual data inputs that you want to have one of them appearing at the output of the multiplexer. So we will connect the output of the multiplexer to the input of the time position. If I'm not wrong, the first input to the multiplexer will be an integer variable. And we will refer to this in the visualization. Then we can connect these to the other inputs of the multiplexer as well. I don't need this max S. If you go back to the visualization, let's in the visualization toolbox, let's look for the combo box integer. In terms of the variable, you can connect it or associate it with the max select. And then depending on the value that we have here, one of these two time positions will be selected, and it will appear here, and then that will be used as the time position input for our axis. Okay, now let's see how it will work in action. As the first step, again, we would need to use the MC underline power to power up our drive. Now our drive is ready. In terms of array size, let's take 10 elements. You can see here that we have 0, 1, 2, and so on and so forth in terms of the values. By default, 0 is used. When 0 is the input, the first data input to the multiplexer will be selected, and it will appear at its output. So the first one that we had over here will be used as the init position time input for our drive. If I make it 1, then the second one will be used. Let's see what happens now. So you see that the kind of movement was different with the one that we had. Now if I execute it again, now we have the relative. No, just a second. Let me check it for the second one. It is still in the absolute form. I will make it false to make it relative. Now you should see the difference. Yeah? Let me make it 0. The movement now refers to the first one. If I make it 1, we will have the relative kind of movement. It goes forward and backward, and then after the selected number of the time position elements used, the drive will stop. You can always see the visualization and the code together. So over here it's not obvious which inputs goes to the output, but for the mux, but depending on the 0 value that we have here, the first data input appears at the output. Alright, so I think that's all that I wanted to show you in this video. I hope you have learned how to use the MC Position Profile, how to provide the input in the form of time position kind of data, so data type, and how to initialize it, how to set the kind of the movement, whether it will be in the form of absolute position or the relative position, and also how to use the mux, the multiplexer, in order to select among different time position arrays that you might have. I hope you find this video useful. Please don't forget to like, comment, and share the video with the others. Thank you very much for spending time on watching this video, and see you in another video later.